Alright, this video is going to be a quick tip for what to do when you run out of base on your LL scale near 1. If you look at the LL scales down here, they get to be very large here, but as you go to the left on the scale and continue down LL2, LL1, LL0 if you have it, you notice the numbers getting closer and closer to base 1. Okay, and the question is, what do you do if your base that you want to use is less than 1.001, about there? Well, the trick is from calculus. If you read from the LL scale to the D scale, then you read the logarithm of x, where x was what you read on the LL scale. And so the trick is, if x is near 0, natural log of 1 plus x is about the same thing as x. So if we look at 1.027, we could find that on LL1. Here's 25, 26, 27. And we look on the D scale, you see that on the D scale you have 2, 5, 6, not quite 27, which would be there, but something which is close, adding 1 to that number on the D scale. If you look at LL0, if you have it, and you find that 1.0027, you see that it's about here, and you see that that's even closer to 27 on the D scale. Okay, if you needed a scale which was containing numbers like 1.00027, that scale would essentially look like the D scale, except adding 1 to it. So for example, you want to compute 1.00023 to power 3. You could simply find 2, 3 on the D scale here. Align the 1. Now I know I'll have to come out to power 3. Now for power 3, you're still not off of that imaginary LL, I don't know what you want to call it, LL01 scale. And so your result there, that looks like 669 or so. That's still 1.00069. It's almost like you multiplied that by 3. But if you want to step that up to 30, then you could read that number on LL0. So the 30th power you would read down here on LL0 looks like 1.006915. Okay, and let's put an additional one in here. 1.00023 to the 300 could then be read on LL1. Let's see. That looks like 1.07, let's see, 715. Let's check that against the calculator. Not bad. Okay. Now again, if you don't have the LL0 scale, you can do this as a substitute for LL0 as well, but in that range you will lose a little bit of accuracy. Now, what about the LL scales for logs, for bases below 1? So you want 99936 to be your base, and you see that your LL 00 scale or -0 scale or whatever your slide rule calls it, doesn't go below 999. The point is, your next imaginary scale could be used. Though the trick for these is that you need to take the complement of the number. So here, thinking about our original scheme, x is a negative number, and to get 99936, you need 64. So I'll find 64 on the D scale. Okay. You can see that's not too far from where it is on LL0, with 1 less 9. Okay, and then for the 450 power, I'll align the 1. Now let's be careful. I'll align the 1, and then if I come out to the 4, 5, that's moved me up from the imaginary scale to the LL00 scale. Okay, and that represents power 4.5. So then going up to the next scale, LL01, that's 45. Then going up one more for power 450, I'm on LL2, you can see there, and I read solution about 0.75, a little under, but let's put it at 0.75. Okay, hope you enjoyed this video, and hope you now can extend your log-log scales for bases close to 1, even without extra scales.